Next question which can be asked is dynamic memory allocation. Memory which is allocated at the runtime of your program is called as dynamically memory allocation, dynamic memory allocation. This is done using new operator and delete operator. In C it is done using alloc and malloc. In C++ it is done using new and delete operator. We understand this by example. Inside the program we are creating a pointer variable p which is of type integer. Initially inside the pointer we are storing null. Now we have to create a memory to store an integer variable, therefore we are using new operator. We are creating a single integer, therefore int. This will create one memory location for storing integer and address of that memory location will be written in p. In the next line we are checking not of p. If the memory is not allocated, it will throw allocation error failed. Else you can access p using value at the address operator. Star p, value at address p should be stored as 29 and we are printing the value of p. P will be displayed 29. So in the first example, using new operator, we have created a memory for integer, stored the integer and displayed it. In the next example, we are creating a memory for float and storing a value inside a float directly in a single line. So we have created a float pointer r. Using new, we are allocating a memory for float. We are initializing the float by 75.25. So this will return a memory location. That memory location will be stored in a pointer variable r. When you write star of r memory at that address operator, it will print a value 75.25. So in the first example, we have printed an integer. In the next example, we created a memory for float and stored the value and printed a float. In the next example, we are creating a variable having multiple memory locations, storing the address in a pointer variable and then printing it. So we want 5 integer variables are to be allocated, memory location are to be allocated for integer. So n is equal to 5. New int n. So how many integer memory location are to be created? 5. Note here we have used opening square bracket, closing square bracket, therefore value will not be assigned but the memory will be allocated. So you will get 5 memory location. Starting memory location address will be stored in q. If q not equal to null, memory allocation will be failed, means address is present in q. So you want to print store the value in memory location. So q contains address. Q of 0 first memory location will be stored 1. Q of 1 first memory location will be stored 2. Q of 2 next memory location will be 3. Q of 4 will store 5. Again we are starting a loop from 1 to 5. Q contains start memory location. Q of 0 will be 1. Q of 1, Q of 2, Q of 3, Q of 4. Subsequently print the value at that memory location. This is the second way of accessing value at the memory when you have block of memory. Address name in square bracket index, it will access the 0th memory location, first memory location, second memory location by incrementing the address subsequently according to the integer or according to the float. If it is integer, if it is required 2 bytes, then it will increase by 2 bytes. If it is a float, the next memory location, to get to the next memory location, it will increase it by 4 bytes. Now, this was new operator to allocate the memory and store the memory. In this first, we allocated the integer, stored the integer, printed it. We allocated the float, stored the float, printed it. We allocated the memory block of integer, stored integers and we printed it. If you want to delete it, we use delete operator. Delete p will remove a memory location p, delete r will remove memory location r, integer float. If you want to free block of memory, then you have to write delete operator inside the square bracket, give the memory pointer name. In this case, memory block was allocated in q, therefore delete square bracket q. PRQ, memory was deleted.